In today's video, we're diving into Scikit-Learn, one of the most popular machine learning libraries. And you're going to learn how to build your very own machine learning pipeline from scratch. I'm going to guide you guys through step by step from data encoding, scaling, and transforming. Everything you need to know to create a streamlined pipeline for your machine learning model today. If you're ready to level up your machine learning skills, this is the perfect video. Welcome back to the channel. Welcome back, guys, for another episode of Code with Josh. For obvious reasons, I'm Josh, and I'm stoked to have you guys here. Before I dive into today's video, do me a favor and help me out. Hit that like button and subscribe. That really does help out my channel within the crazy YouTube algorithm. Now, today's video is all about building your very own machine learning pipeline. And we're gonna do this through stages. We're gonna build out your own machine learning model with a practice data set. And I'm gonna share with you guys how we can create a pipeline for your numerical data, your categorical data, and then bringing these pipelines together to integrate a machine learning model. Guys, the first link in the description is my weekly Python newsletter, where right now I have just launched a new series surrounding machine learning. It's the first link in the description. Head on down there, check it out, and join my weekly Python newsletter for all the action I got going on for you guys. If you're ready to start building your own pipeline, let's get right into it. All right, here we are, guys, about to build out a machine learning pipeline. Now, the goal of this project, this pipeline, is really to create a model which is able to estimate a vehicle's CO2 emissions based on the features of a vehicle, like the size of the engine, the fuel consumption, the brand, all those characteristics a car has. We're going to build a model which can hopefully predict the CO2 emissions for a vehicle, and we're going to do this through a pipeline. So I can show you how a pipeline works, how we encode data as well. So I've already labeled out the steps here. All right. I like to be thorough, leaving notes in our code. View this like a notebook. With all of our imports, so, okay, first things first. Really, in your terminal, okay, pop this up, open it. We need to install certain libraries if you don't already have this yet. So you should be doing pip install. We'll need pandas to load the data, numpy for creating our arrays, and then we need scikit-learn for the machine learning process and to build out the pipeline. You can run this, install these, skip any framework you already have installed. I already have them. So beginning up top here, I'm just going to import pandas as PD. Okay, that's our standard convention there. I'm going to import numpy as MP. I want to be able at a later stage to export this pipeline, so I want to save it so I could use it later. I'll get into this later. For this, we're going to import a module called joblib. Then really comes all the scikit-learn imports. Okay, so from scikit-learn, I'm going to tap into the module model selection. We're going to import train test split. This function splits our data set into a training and a testing set. You can view these for now. I want you to think about flashcards. Okay, and I'm going to circle back to this analogy later. Since we're building a pipeline out, I'm going to say from sklearn pipeline, we're going to import the pipeline itself to link things together. We are going to say from sklearn, we want to tap into the compose module. And compose, we want to write something, right? Really, I'm going to import column transformer. This is going to allow us to link the different pipelines together. One is going to be for our categorical data, all the data that starts off as a string. The other will be our numerical data. Then we can go through our steps for preprocessing. So really, preprocessing is like cleaning the data, preparing it for the model. This is just going to convert all of our data, giving it a mean and a variance of a range of 0 to 1, typically, depending on how we preprocess this. I'm going to import standard scalar.
And then I'm going to import one hot encoder. This is going to be used for encoding our categorical data. From Scikit-Learn, we're going to do impute, and I'm going to import here simple, where is it? Simple imputer. This will handle any missing values we have in our data. There's a lot going on here. Okay, the model that I'm going to use today is actually going to be random forest regressor. Okay, so I'm going to create a random forest. This will be like a regression task. And a random forest really has a bunch of decision trees. A decision tree, if you know what that is, a forest has a bunch of trees in it. Then we need a way to test or evaluate your model. This is the Scikit-Learn metrics module. I'm going to import here mean squared error. I'm going to dive into all these, okay, towards the end of the video. If you want to understand what each of these will do, don't worry, that's going to be covered here. We're going to do R2 score, and we're going to do mean absolute error. Okay, so kicking things off, these are the imports we need for this pipeline, this project. As you start practicing more, these will become native to you, more natural. But I just want to take you guys through the pipeline process. So I'm going to load in our data. Now let's talk about our data very quickly. Let me put it in here first. Vehicle emissions CSV. Okay, you can get this over on Kaggle. I'll actually link this data set in the description of the video if you guys want to follow along, right? But this is going to be our data set we're going to use. And because we're trying to create that model, which is going to estimate the vehicle CO2 emission, I want you to look through this. A lot of this is objects, they're strings, and Acura. A model only understands numbers. This is why we need to encode our data. So Acura, the model, the vehicle class, we have the transmission. All this needs to be, encoded so the model can interpret this data. Okay, a lot of these are already numbers. We'll still clean it up to prepare it for the model as we should, right? But others need to change. So really, I'm going to print off two things. Okay, let's just get an idea of what the head looks like, and let's get the basic info about this. Run your code. Give it a second. It has to go through everything.
Guys, real quick, if you're getting value in today's video of machine learning and pipelines, help me out, hit that like button and subscribe. That really does help out my channel.
Okay, here we go. Let's make the terminal a bit bigger. Okay, our head, I'll have to print the head. Info automatically returns that for you. So, if you want to rerun it, okay, I don't have head because I should have printed off the head. But that's fine. I won't rerun it for this. But you can see here, okay, look at these. Make, model, vehicle, class. Those are all objects. That's a string in Pandas. We have transmission is also a string. Everything else is either a float or an integer, which is good. We'll still need to clean it up, okay? But this will give you an idea of what do you need to encode in what route we're going to take. Either categorical encoding, that's when we encode or convert strings into numbers really for the model, or numerical encoding is when we clean up and prepare the numbers we already have. Okay, so going down here, I want to create the features in the target variable. The features are really the car features, for example, but really it's just a column in your data set. Okay, so all of these are features of the car. They're features of the data set. I'm actually going to, I'm not going to copy that because I'll have to type it anyways. Let's create the features. So X. X, if we view these as flashcards, you can view X as the front of the flashcard, okay? And really, X is going to be our entire data frame, but I want to remove the answer. The answer we already have in our data set is, where is it? CO2 emissions, right? I don't want my model to see that because we're training the model to predict the vehicle's CO2 emissions. So we want to drop that from our data set. So X has all the other features except that. And we want to target the column, so X-axis. Then Y is like the back of the flashcard. Y is the answer to the front of the flashcard. Okay, that is the answer we're giving it. Okay. So we have our features, that is X, then we have our target variable is Y. I want to now create two lists. I want to split the columns up into our numerical columns and our categorical columns. These will both be lists for now. So what in our data is already a number? Okay, if you have your terminal, I think I trashed it. Yeah, the info, if you ran your code, that tells you what already is a number and what's not a number. So, well, for you guys here, let's actually run that again, and I'll use that to help me out here. Okay, so anything that is already an int or a float is going to go in numerical columns. So I'm going to take model year. We're going to have engine size. Okay, they're already numbers. And I'm just going to go through and I'm going to drop each of these in here. Okay. Cylinders, fuel consumption in the city. We need to do fuel consumption in the highway. And then I guess we have three more still, two more, right? We're going to drop in this one. And then our smog level, which I don't know, smog level, I guess we need that. It'll help our model out. Okay, so these are everything that we have as a numerical value already. Okay, the categorical is really everything else. So this might actually be faster to type. Make, we have model, we have vehicle class, we have transmission. Anything else? Nope, that's everything. Okay, so make, model, vehicle, transmission. Smog level is still an integer. Okay, so that should be fine. Okay, so I've split everything up into two lists. We have our numerical columns and the categorical columns. We now want to start off the pipeline. Now a pipeline, imagine different pipes. In the end, we're going to link them all together into a single pipeline. But currently, let's start with one piece of the pipe. Okay, so coming down here, I'm going to create my numerical pipeline. And we're going to use the pipeline class that we imported. Okay, inside here, we'll put a list. Now, in this pipeline, we're going to do two tasks, really. The first task, we're going to use the imputer to fill in the missing values. So I'm going to say this is the imputer, and we're going to use the class we imported, simple imputer. This will handle the missing values with the average of the column. So if one's missing. The strategy we're going to use for this strategy, there it is, the mean. Okay, so if it's missing a value, I'm just going to drop in the average of that. Okay, then we want to use our scalar. For this, we're just going to go standard scalar. This is going to standardize the data to have a mean of a 0 and a variance of 1. Okay, so this is the numerical part done. The next step would be our categorical categorical pipeline. This is another piece to the pipe. Okay, this time we're going to do two things as well. In the first part of the categorical pipeline, we are going to apply our imputer as well. Okay, so we're going to drop in here imputer. We are going to use simple, where is it? Imputer. Okay, this time, if a category is missing a value, we can't do the average because these are strings. So I'm going to say most frequent. If it's missing a value, let's use the most frequent occurring value in that column to fill in the value. And then our last one, we need to do some encoding. So encoder, I'm going to say one hot encoder, and this is going to convert all the strings into binary, right? And inside here, for testing purposes, I'm going to say handle unknown, ignore. This is going to ensure the encoder handles all those unseen categories without any errors while we're in the testing phase of this. So we have the first two pieces of the pipeline. I want to now join these two together. So I'm going to actually put a label here for us. Let's just say join the pipelines together. Okay, that's really what's happening. Since we're joining the pipelines together, this step I will call preprocessor, and we're going to use column transformer. Now, we're joining together two pipelines. Okay, so the first one we're joining, this is our numerical pipeline, and I'm just going to drop in here numerical pipeline. And what data goes into the numerical pipeline? Well, all of these numerical columns. So numerical calls is the data that's going to go through this piece of the pipe. All right. So down here, the pipeline is going to accept numerical columns. Okay. Then we have our categorical pipeline. So we're going to say, let's take our categorical pipeline, and which piece has to go through that pipe? All the categorical columns. Okay, so this is the pre-processing stage. We've linked together two pieces of the pipeline. Closing off the pipeline, let's get it all together. So I'm going to create my final pipeline. We're going to use the pipeline class. And inside here, we now need to join together two things again. What do you think we're going to join together? Well, I now have the preprocessor done. That's like the cleaning stage, pre-processing the data. In the next one, we want to give our model, because that's where the data is going to end up. And we're going to use our class that we imported to build the model, random forest regressor. This is our pipeline. We went through different pipes. We connected the two pre-processing pipes here. Then we took our preprocessor, and the output of this is going to be going into our model. It's going to be flowing into the model. Okay, so I have combined the pipelines. We did that. Okay, we have this pipeline. We're ready to split our data set into a training and a testing set, and then start training our model. So we're going to have X-train, X-test, Y-train, Y-test, and we're going to use the function we imported, train test split. Now, this function returns 4 values. I want you to think of these values as flashcards. The X is the front of the flashcard. The Y is the back of the flashcard. It's like when you're learning to study something. On the front of the flashcard is a chicken. On the back of the flashcard is the word chicken. Train is going to be used to train the model. So when the model is learning, the model is allowed to view the front of the flashcard as well as the back of the flashcard. Once the model is done learning and we want to test how well the model learned, we are only going to give the model the front of the flashcard. The model cannot see the back. It needs to use the front of the flashcard to make a prediction. Then when we go through to evaluate the model, we can give the answers to the flashcard to compare to see how well the model learned. Inside here, let's give it our features, which is X, and we're going to give it our target variable, which is Y. Let's create a test size. So I'm going to say 20%, 0.2. That means the flashcards, X test and Y test, that is 20% of all of them. Okay, and then we're going to try to ensure consistent results across every time this runs. So typically we would do something like random state and give it 42. So I have these flashcards now. Let's train our model. So let me keep on here, train the model. Let's take the pipeline and we're going to say fit. Fit is a function from Scikit-Learn which allows you to train the model. When it's training, it's allowed to view the front of the training flashcards as well as the back of the training flashcards. Okay, so here it's learning. Once the model learns, great, it's done. I want to create a prediction. I'm going to take my pipeline and we're going to use predict. This time it can only view the front of the test flashcards. Okay, that's it. It's done. All right. Really now we just want to test how well it learned. Okay. If you guys want to actually see here, why don't we do this? Let's view the encoding. That was done. Okay, so let's just check out how all those strings were converted to numbers. actually. So let's just, yeah, this is a good test. Let's say encoded columns is equal to our pipeline. Okay, we're going to say named. Is it going to pop up for me? Name steps. There it is. I want to go through the preprocessor, which we named that. And we want to go through the named, let's see if it pops up, transformers. Come on. Nope. Transformers. Okay, name transformers. And we need to go through here the categorical transformers. And I want to go through to show you guys the encoder. I'm calling this encoder, right? Because up here, I'm targeting this. I want to see the output of this. So we're going through those. Okay, let's get feature names out. I want to get them out. And we want to get them out of the categorical columns. Okay, and I can just print off now encoded columns. Okay, let's run this and let's check out how that actually did the encoding for us. Okay, so I am thrown an error. A given column is not a column in the data frame. Okay, we're okay so far. I just need to go and fix this bug. Did I delete something? Fuel consumption in city. So that's apparently not in there. Well, that's not accurate, but okay. So fuel consumption in city. Let me just go over and check. Fuel consumption in city. This one. Okay. Fuel consumption in city. Oh, wait, did you see that? Oh, that's highway. Whoops. Oh. It's because this parenthesis here, I didn't actually copy that one. Okay, that will handle that. Okay, I'm gonna run this again. Okay, another error, another column. Okay, which one did I misspell? Vehicle class. Okay, is the C lowercase? Oh, underscore. Okay, so vehicle underscore class. Okay, those need to match our data set. Ugh. There we go. It's doing its thing. Here's just the info that we printed. Boom, look at that. Okay, so this is all the data that it went through and it actually encoded. Okay, currently it's outputting strings, but it's telling us what it went through, and all of these were encoded. So these were all the makes, the models, everything like that it went through. Okay, so that's a good tactic that you could double check if you want to go through and just check, okay, what was encoded. Now we want to evaluate. We have a model. We have this prediction. How well did it perform, right? So we imported a few things. We imported mean square error, so MSE. I'm going to use the function mean squared error. We're going to give it the back of the flashcard, and we are going to give it the prediction, okay? Now, mean squared error is the average of squared differences between the actual and predicted value, all right? So really, the lower this score is, the better, okay? We are going to have, I mean, if you wanted to get the root, you could do root mean squared error. I imported NumPy, I haven't used it yet, so let's do that. Let's say NumPy, let's get the square root of that, and we're just going to give it our MSE. Okay, so inside here, once again, the lower this is, the better. In fact, I won't even print this one. I will just print this to get the root of it. What are some other ones would we import here? We have R2 score and mean absolute error. Okay, so for R2 score, I'll call it R2 is going to be equal to R2 score, score, okay? Once again, we need to give it our Y test and our prediction, okay? The higher, the better. Okay, so if this is, it's going to return a decimal range from 0 to 1. If we got a 1.0, it means the model predicted perfectly, okay? Don't expect a 1.0. That'd be a lot of tuning and things that we have to do. Then lastly, we have mean average error or mean absolute error. Let's see what I imported here, mean absolute error. Okay, let's give it our Y test and our prediction again. And this one here, we're going for a lower score. Okay, this is the average of absolute differences between the actual and predicted values. The R2 score is the proportion of variance in the target variable. Okay, so I'm just going to come down here now, and we're just going to go through and print these. I'll just be like model performance. Okay, we can print off. Let's start off with our first one. Let's do like an R2 score. So like R2 score. We're going to drop in here then. Oh, wait, what am I doing? Come on, go back. We are going to drop what? R2 into there. Okay, nope, R2. We can print off the root mean square. So root mean square error. We're going to drop in here our MSE. Okay, whoops, there we go. And then our last one is going to be our mean absolute. So obviously mean absolute error. Okay, and drop in here MAE. Okay, let's check your model, our pipeline's performance, run your code. Let's see what we get. Okay, remember, R2, we are going for the highest number possible, up to a 1, and the other two, the lower, the better. Okay, so it's doing its thing. There we go, look at this. So that's actually pretty high. So my R2 score is a 975. That's good. You could do some stuff maybe to get this lower. I've seen these really high, so this actually isn't too bad. Mean absolute error is also quite low. Once again, if you do more hyperparameter tuning, I talked a bit about that in the last video. I'll try and link that. You might be able to get these numbers down. Okay, this is great. The last thing I'll do is you have a working pipeline. So I want to save the pipeline that we could use later. So I'm just going to say joblib. We imported that. I want to dump. I want to save the pipeline and create a file name. So vehicle emission pipeline .joblib. Okay. Run your code. Ideally, it should dump us out a file. There we go. So we have saved the pipeline, right? We can't view it, but this is our pipeline save that we could use at a later stage. Guys, this is great. Not only did we build out a model to check for the CO2 emissions of a car, but you guys right here, you learned how to build a pipeline in machine learning. Now, this was an easier example I tried to put together for you guys, but I did take you through the steps of this pipeline, and I hope you guys enjoyed today's video. Well done.
And there you have it, guys. You have crafted your own pipeline from scratch. This is the next step in your machine learning journey, learning how the pipeline works, how we can take data from different columns and stages, bringing it together, scaling it, encoding it, and processing it, outputting it into our machine learning model. If you guys got value in today's video, help me out, hit that like button and subscribe. Drop a comment, let me know what other key videos would you guys like to see going forward surrounding machine learning, as I'm hoping to embark on a new series here on the channel for you guys. And remember, the first link in the description, that's my weekly Python newsletter. Right now, I have just launched my own machine learning series. Head on down to the link in the description, join in on all the fun. I will see you guys in next week's episode of Code with Josh. Until then, Python crew,